Welcome to Programming with Qt Widgets. I'm Jesper Pedersen from KDAB. In the previous episodes, we saw how you connect signals and slot. In this episode, it's time to see how we can add signals and slot to our own objects. Had the story ended at the beginning of this episode here, it would have been a very boring story. You would have learned how to take a slider and connect to a spin box or a slider to an LCD number or some other classes starting with Q. But it doesn't end here. It's possible for you to add signals to your own classes. So you can start telling the world about changes in your classes by emitting signals. And similarly, it's possible to add slots to your own classes, and that way you can tell the world, hey, you can notify me through a signal slot connection. We'll see now how to do that. If you want to add a slot, the first question you need to ask yourself is, how backwards compatible do you need to be? It might be that some of your code still needs to be compiling on Qt 4. Somewhat unlikely. It is 2023. It's more than 10 years ago since Qt 5 was released, but nevertheless. It might also be that you just downloaded some code from the net that looks like what I'm showing you now, and in that case, I understand it's good to know what is going on. So if you look at the code here on my screen, you can see that your slots are in a public slots section. It might be a protected slot section or a private slot section, depending on who should be able to connect. But most often you connect your signals and slot from the outside, in which case you want to have a public slots section. Also, you need to add this really weird looking things called Q_object. It's a macro that will expand to a lot of code, and you need that upfront in your class. Okay, let's reiterate now. It's been 1 minute and 16 seconds into this video, so it's time to reiterate. If you just want to develop a regular Qt 5 or Qt 6 application and use the modern way of connecting, then you do not need the public slots. You just put stuff in your public section. You do not need a protected slot. You just put it in the protection section. And neither do you need a private slot. You just put it into a private section. You will, however, want to have the Q_object macro at the very first line of every single class that you do that is subclassing from QObject. And the reason for that will be somewhat apparent in the next video. Just get into that rhythm right away. Okay, let's see an own slot in action. I have a very simple, but still very, very useful application here. As you can see, it prints out a second at a time, and it's basically a stopwatch. Let's see how it's implemented and see how fast I can do it. The stopwatch here is subclassing from QObject. It has the Q_object macro in it, and it has one private slots because I'm the only one to listen to this. It's called add 1 second. And in the add 1 second, I set up a timer here. Well, that's the add 1 second. In my constructor, I set up a timer. I ask the timer that every time it times out, it should go, or it emits a signal for the timeout. It should go into the add 1 slot. And then I start the timer to go off every second. The add 1 second slot down here, simply increment an instance variable and do this beautiful stuff here to figure out how to print out the time here, and it debugs that out on standard output. Not much going on, but it's still a very used pattern that you'll see in a lot of places. You have, say, a dialog. The dialog has, I don't know, 50 different widgets, and most of these widgets you're interested in learning when the slider is moving, when the user clicks the OK button, and other things. And what you do is that you go through each of those and you connect to this. So you have all your slots in your own class and you connect them all to this, and then of course different slots. Just to prove you that I'm not tricking you here, let's run it again. This time it's not private slots, but just private, and that's okay because I'm using the Qt 5 or the modern way of connecting. If I had done it with the signals one here, signals, or signal, timeout, int, and stopwatch, well, timeout doesn't. And in here, add 1 second, and let's run that again. You'll see that this time it will not work. It will compile. That's the annoying thing about those signal slot connections here. Ooh, timeout was not declared in the scope. Did you mean timer T? What? Connect? That's because I didn't get the signal spell correct. Signal, there we are. So once I got that wrong, it tried to actually pass this. And now, for the love of God, I cannot type on my keyboard. There we are. And now it just says, ooh, I cannot connect to that. And the reason for that is that it was not, it was not declared private slots. But really that is beside the point. What is the key takeaway here is that I have this slot inside of my class. That's the connecting from a signal from outside to a signal from outside. That is a use case that is very cool when I need to explain to you what signal slot is up front, but 99, give and take, % of the time you are connecting from a signal from one of your children to, this. Cool, right? Why is this piece of meep so slow? Do your boss tell you that all the time? Well, there's 2 solutions to that problem. Either find yourself a new boss or solve those problems with your application being slow. I cannot help you with the new boss, but I can help you with it being too slow. Million Wolf of KDAB has created a tool called Hotspot. Now, just because you are not connecting signal slot completely from the outside doesn't mean that signals is not useful for something for your own components. Rather the opposite. Often you're creating components of a part of your user interface. You have this widget representing something that you are using one or multiple places in your application, and you want it to be as much of a component as possible. So it's a black box to most users of it. And therefore you have a number of signals being emitted from it. And in that situation, that is when you want to emit signals yourself. So let's see how you add signals to your own classes. Again, remember public slots and so on. I told you slots is not needed most of the time, but signals, that's a new section in your class. And you add that signals section, and in there you have all your signals. Here's a signal called value change. They all return void because we're not using the return type for anything. And then the list 0, 1, 800, I don't know how many parameters your signal should bring out. Usually it's 0 or 1, but you could bring out multiple. So range changed with 2 integers specifying the start and the end of the range. And you also need the Q_object macro. And this time it's not optional. You do need the Q_object macro. And as I told you earlier on, you always want Q_object macro when you're subclassing QObject or one of its subclasses. Now the example I'm going to show you is not a very realistic example, but it's the best we can do with what we have learned so far. I'm even going a bit further than what we've learned, but only one episode ahead. What you'll see here is I have a connection of a window. So I have a window class here I'm creating an instance of. It emits a signal called position changed, and that's what I'm implemented as my custom signal here. And it goes into a slot. Well, it goes into this standalone function called print window position that prints out the window position. You see my new window position is this position here on my screen, and when I move it around, you can see it prints out new position for every move. The actual implementation of window is super simple. Its subclasses from QWindow, and QWindow has a virtual method called move event. You can see it's overwritten here, so that comes from QWindow. And I have this signal of my own. I need Q_object, I need the signals section here, and I need the position changed that brings out this new position. move event simply calls the superclass's move event and then call emit, the name of the signal, the actual parameters to that signal. Hang on there, Jesper. Wait a minute. Can you just go back to your header file? Okay, I can do that. In your header file, I can see, Jesper, that you have this signal section, void position change. If I were like covering up that part, it looked very much to me like this was just a regular method that you had declared there. But if you go over to the CPP file, I don't see that method anywhere. Where did it go? Very good question. It is indeed a regular C++ class, but it's not implemented by you. It's implemented by a tool called mock. Mock is just a game of words. It's mock stands for Meta Object Compiler, and the game is that it's a play of word or whatever you call that, is that mock. That's what you do when you're just putting something together real fast. If you're a native English speaker and I'm wrong, do correct me below in my comments. I've been saying that for 20 years in class now, so it would be somewhat embarrassing. Anyway, what happens is that your tools, that your QMake or your CMake or whatever build tool you have, will recognize that there's Q_object macro inside of your setup there. And then it'll say, okay, if that is so, then I need to run mock. And it'll run mock, it looks like this, mock -o. That's where should it go? Into mock_myClass.cpp. And it does that from a class from your header file. So it'll read your header file. And mock is not a full-blown C++ parser. So there are some limitations, but in most cases it works out fine. Mock will read your header file and spit out mock_myClass.cpp. Now, it will compile your regular class and it will compile this mock class and it will link it all together. And of course, this is just a pseudocode, but that's the idea, that it will link all of your object files into your binary. And that is how your signal is implemented. Let me just show you, because I found that file. Here is void window : position changed, and it took a Q point, bringing out a Q point, at least that's conceptually, takes a Q point here, and it calls this stuff here. Don't worry if you don't understand it. We'll actually dive into that in the next video. I said that it would work automatically out of the box and everything, and it will usually. There's two things to notice. First of all, there are a catch, and I'll tell you about that in just a second. And the second thing is that if you're using CMake, then you need to add a line to your CMake file. Let me just show you here on this project. Remember, we had this CMake -projects tool, and what it does, it generates you a CMake list.txt file, and in here you can see exactly what you need to do. You need to add this set CMake automock true, and what CMake then does is that it will read all your header files and search for Q_object in one of those header files. And then it will work out of the box. Except when it doesn't work. And it's when it doesn't work that you get really frustrated and start Googling. But I'll draw a picture for you now that will make you very well understand what goes wrong when it doesn't work. It looks like this. Here, and sorry again for my inability of drawing rectangles. Here I have my project.pro or CMake list.txt. And what I use that for is that I run my tool QMake, and that generates me, if I'm on a Linux system, it generates me a CMake file. In that CMake file, there is a target that says that whenever this file here, my x.h header file, for example, whenever that changes, it should run mock. And what I get out of that over here is mock_x.cpp. But this whole target, this whole thing here, will only be in my make file if my mock, whenever it was executed up here, whenever I executed mock, whenever I executed QMake or CMake, if it actually in my x.h file found Q underscore. Otherwise, that target will not be in there. And you could say, well, would it be nice every time I run make that it would test whether that's the case? And yes, you could say that. But what you're really asking for, think careful now. You're asking for the very odd corner case that every time you run make, you should open up all your header files and pass all your header files to see if there is a Q underscore object macro that all of a sudden has been added to that particular header file. Because how would you otherwise know? Well, I guess you could rely on that header file changed, so we should reopen it. Hey, actually, that's a great idea. Maybe we should talk to the Qt people and those people that are implementing CMake to do exactly that. But it doesn't do that right now. Okay, so let's see what goes wrong when it goes wrong so that you at least have had a chance to see that. I've commented out any usage of the signal here now. And when I compile it, you'll see it'll complain on compile output. It'll say, note, and that's from main window.h, note, no relevant class is found, no output generated. But that's actually, I don't know if we can even spot it up here. That is mock that is complaining. Mock tried to read here, but it didn't find Q underscore object anywhere in here. So we'll go up here and say build, run qmake, and we'll build again. And this time, nothing to be complained about. I can even, well, let's just make a change here so you can see when it compiles it, it doesn't complain about anything. Then I say, okay, let's use signals and slot. That seems like a really good idea. I will add this, and now it will complain with a very weird error message. It'll say undefined symbol vtable for window. Let's look at the compilation output here. It's the linker that's complaining, and it's complaining that it doesn't know the vtable for window at this position here. That's for this class. And of course, I know exactly the error now, but I urge you to go home and try this exactly what I did here on your own compiler at home, because it might give you a different error message. And the cure here, of course, is to remember, okay, I do not have that target that gets me that mock underscore window.cpp. So if I just build now, run qmake, and I build again, now we run mock, I get that target, the linker is happy. To understand what exactly this error is, you'll have to watch the next episode where I'll go behind the scene and understand what is going on when I emit a signal. Until next time, have a great